Look at the beautiful Cheesequake State Park. New Jersey, Pawnee's sister city, and we're gonna learn about their parks and hopefully use that to improve our parks as well.
I thought we were coming here for some cheesecake, maybe even like cheesesteak. We're near Philly, so this girl is just so into parks. Like Cheesequake State Park, like what is she doing?
It is so important to get your bug spray. In New Jersey, there's all kinds of mosquitoes everywhere. They're everywhere. One tried to bite me through my pants, but I did not let it. Got that bug. So we're here in our sister city of Matawan, New Jersey, looking at how they run their parks so that we can make our parks back home in Pawnee even better. We're gonna see like how much the values that their parks provide to the people around them. We're gonna look at all the natural cycles going around in their parks and see how it looks to Pawnee. And we even got Jerry over here gonna show us the local flora and fauna.
Yeah, I mean, right now we're in a deciduous forest. It's pretty lit. There's lots of plants around, lots of different kinds. You'll see that there's a lot of really rich soil because of all the dead leaves that have been decomposing. A lot of bugs, too, contributing to the natural ecosystem. Jerry's Plant Talk. It's free plants. Check this out. I found some New York ferns over here. So ferns are a member of the Pterophyta phylum, and what makes them unique from other plants is that they reproduce via spores as opposed to seeds. And now these don't have any, but normally you can see them on the bottom sometimes if you look around. I can't find anything right now, but yeah, ferns are pretty unique. They've also got special tissue within them that circulates water and other nutrients throughout these stems. These little leaf things are called fronds. So hello there. I found another member of Kingdom Plantae. These are from the Lycophyta phylum. This is a club moss right here. So these funky little guys have been around for a very long time, and they're a little bit simpler than their brothers, the ferns, because while they do reproduce via spores as well, ferns have a lot more complex vascular systems called megaphils. These only have microphils, which means that their leaves only got like one vein running through them. So they're pretty simple, but as you can see, clearly evolution has been in their favor because they're still around after all these years. Angiosperms, which are the flowering plants, and this is a dicot. This is an oak tree right here. And how we know it's a dicot is because if you pick up one of the little seeds here, this is an acorn, and it's empty right now, but while it was still full, it has two embryonic leaves in there called cotyledons, and what those are embryonic leaves. So they're different from monocots because monocots just have one, thus the mono prefix. Dicots have two cotyledons in there. So there's lots of varieties of dicots. It's an extremely varied phyla, and anything with the two embryonic structures is going to be a dicot, and they're fairly complex structures.
This acorn empty.
So what we've got here is a pitch pine. And pitch pines are part of the Coniferophyta phylum. And what makes plants in the Coniferophyta phylum unique are that they are gymnosperms, which means they keep their seeds in these little seed cones. This is a pine cone right here from this pitch pine. And most plants in Coniferophyta are trees, but there's also a few woody shrubs as well. And Coniferophyta plants are extremely important to ecosystems because they typically take up large expanses of land, and when they do this, they create this thing called a carbon sink in which they can sequester carbon compounds, and that's extremely important to ecosystems, especially the salt marsh ecosystem right here. Okay, so if you look around here, we've got a bunch of plants called monocots.
Look at all these monocots.
And monocots are a phylum in Kingdom Plantae. Kingdom Plantae has a big division in it. There's the angiosperms, which are flowering plants, And there's two types of flowering plants. There's monocots and there's dicots. Again, right here what we have are monocots. And the difference between monocots and dicots is that monocots, in their seeds, they only have one embryonic leaf called a cotyledon, or usually, sometimes there are variations, but mono, one, cotyledon, monocot. And this one embryonic leaf is what makes things a monocot. So again, we've got monocots all around us, and among them there is this native species called Spartina, also known as cordgrass.
So this area is full of decomposers and very photosynthetically active plants. So this really plays into the animal structure around us and the trophic structure. So with all of these grasses, there's a lot of microorganisms breaking things down, which ultimately those become food for like the larger animals such as birds and like crabs. There's crabs here, there's fish here, and those are feeding on the microorganisms which become food for the birds. And then also you see a lot of this grass all around me. It's not really fed upon by the birds flying up in the sky, allowing it to be very photosynthetically active, and then the microorganisms ultimately breaking things down in the soil. So if we look at all this very rich soil we have here, there's a lot of denitrifying bacteria in it. And what these guys do is they release a lot of the nitrogen into the air and it becomes atmospheric nitrogen. But it ultimately cycles back around and is reabsorbed by the soil and is used in nitrogen fixation for a lot of these plants. Additionally, with animal waste, the nitrogen in it is taken into the soil, and a lot of the things that decomposers decompose release nitrogen compounds into the soil as well, which are ultimately, again, broken down by the denitrifying bacteria and released into the atmosphere, creating a cycle. So when all these little guys get their food and they digest it and they poop it out, it goes back into the earth, and it becomes part of like both the carbon and the nitrogen cycles from the nutrients that were in the peanuts that they're eating.
Ew.
Look at this decomposing tree. All of the carbon in it is getting released back into the ground, filled with these leaves. All of these decomposing things, their carbon's getting released back into the ground. Over many, many years, all of the carbon released from these decomposing things gets driven into the soil, and deep down these fossil fuels are created with that are carbon rich. Look at these plants over here. They are releasing carbon dioxide into the atmosphere during cellular respiration, but with the sunlight and the carbon dioxide from the atmosphere, they take it back in during photosynthesis. The carbon cycle. My pal Jerry over here, he's breathing too, releasing carbon dioxide back into the atmosphere, another part of the carbon cycle.
Ooh. Miss Tree? Miss Tree, oh my god, she's freaking dead.
We found some shells, and the shells of most animals and bones as well are made out of carbonates. So when the animals die, they leave their shells behind, and these eventually break down and join these layers of limestone. So this is part of the carbon cycle in action right here.
So Leslie was lecturing me about the water cycle the entire ride over here.
Water travels in a cycle, yes it does. Water travels in a cycle, yes it does. It goes up as evaporation, forms clouds as condensation, comes down as precipitation, yes it does.
So right here you see all this water, and since Cheesequake is near the ocean, because I can smell the salt, it really is everywhere. So all this water over here comes from the ocean and from rain and everything. So the first step in the water cycle is evaporation, and all this water over here gets turned into water vapor from the sun and everything, and it goes up and condenses in the clouds and comes back down as precipitation, which comes and enters back over here. And additionally, you see that we're in a marsh. I mean, look at all the bugs. So all the plants over here, the roots and the really thick soil absorb a lot of water, and they store a lot of water from rain and the ocean and everything. So you see this marsh out here? Well, it's actually really useful. It might be like really buggy and all, but when there's flood, when too much water comes in, these marshlands have the soil called peat, as you see. It's really it absorbs a lot of water. It's sort of like a sponge, and it slowly releases it instead of having it spread out everywhere. So when there's a flood, this all stores it and releases it much slower, preventing the inundation of water in communities. Additionally, the roots from all these plants create the sort of structure that supports more water storage. And also, since we literally live in New Jersey and there's a freeway right over there, all the runoff from roads and buildings and stuff gets stored over here instead of affecting the environment negatively.
So, you want me to find out the value of Cheesequake's ecological services so you can compare them to Pawnee. Interesting. Well, Tom, you started off with talking about the marshes, so let's start from there. Let's look up United States Environmental Protection Agency. Well, it appears from the information on the... Just kidding, I just can't pronounce EPA. Wetlands function as natural sponges, like the sponges you have at home, just think about that. They trap and slowly release surface water. Trees, root mats, and other wetland vegetation also slow the speed of floodwaters and distribute them more slowly over the floodplain. So that shows you the benefits of marshes, okay? This combined water storage and breaking action from roots lowers flood heights and reduces erosion, like I said. Wetlands like Cheesequake, which you were talking about, that are near urban areas, just like ourselves, are even more valuable as they interact with greatly increasing rate and volume of surface water runoff from pavement and buildings. That's a great start. Okay, you can stop. So, instead of buying expensive dredge operations and levees, you could instead just have marshes because they provide the level of flood control that a park like Cheesequake needs. It says that the wetlands along the Mississippi River once stored at least 60 days of floodwater. So this is really beneficial financially. All right, I got a number. So I'm just going to show you what I did. I first researched flooding in New Jersey specifically, and I found a study that said that wetlands annually prevent $428,700,000 in damages. So, right over here, I'm going to show you my calculations. This is our original number, and I divided this by the total amount of acres that New Jersey consists of. So that's 916,000 acres. Divide this, and you get a number of $468.01 per acre in New Jersey. So for every acre, you save $468.01. Now, I found out that there are 218 acres of wetlands in Cheesequake itself. So you multiply this number by your total amount of dollars per acre, and you get a total value of $102,026.18 saved at Cheesequake for having wetlands. Whoa. Wait, I just realized something. You can't just stop there. There's so much more than Cheesequake than just its wetlands. We also have all of the other ecosystems. Look at this, look at this. This is from iTree, at iTree. All right, anyway, look at this. You can also look at all the trees and all the plants themselves at Cheesequake and say that they're helping save money by slowing down global warming. And this is done through the carbon cycle. Now look, trees, we all know, they go through photosynthesis. And what happens is something called carbon sequestration and carbon storage. Now, plants obviously go through carbon sequestration where they convert carbon into biomass. But what's really helping is the carbon storage where it's leaving carbon that way. Obviously, some carbon is going to go back into the atmosphere, but the slower that happens, the less global warming there will be. All right, so through a quick search, I found that Cheesequake's service worth through carbon storage is $6,201,852. This is annually. In addition to that, the carbon sequestration gives them $101,458. So, if we added these three numbers up, we have our total, which is $6,505,334 every year at Cheesequake from Ecological Services. Damn. This is interesting. I noticed that Cheesequake actually has a small problem with nitrogen loading, which is literally any type of pollution you can think of that humans can make. And I found that the damages this can cause are pretty scary. They can change the vegetation structure of the marshes in Cheesequake, which means all like the spaces that aren't supposed to be there can either increase or decrease. Things that are supposed to be on top are now below. It's a mess, and that mess requires money to fix. So why just not have the problem in the first place so that you can save your money? And I got very into this, so I found a solution. Theoretical one, but I believe it can work. So in the nitrogen cycle, you have nitrogen in the atmosphere that needs to get converted into ammonia in the soil by bacteria, and this ammonia converts into nitrite and nitrate and eventually goes back into the atmosphere as nitrogen. So technically, if you increase the amount of nitrogen fixing bacteria and decrease the amount of denitrifying bacteria in the soil, you can decrease the amount of nitrogen in the atmosphere in the Cheesequake area in itself. And the way you can do that is by finding plants nearby, maybe a couple miles away, that have similar bacteria as the marshes in Cheesequake. So you could just take up that soil, maybe disperse it around the marshes in Cheesequake, and that will increase the amount of nitrogen that will get converted into ammonia.